Our unfathomable lead is way out of this world, 390 light-years away. Truth be told, 1 light-year is defined as 6 trillion miles. In mankind's resolved excursion for relaxing the insider mysteries of the universe, we've set out on a mission that goes beyond time itself, looking for replies to age-old solicitations woven into the outer layer of existence. The James Webb Space Telescope, with its unblinking eye, has actually perceived a short look at a construction beginning before the show of stars. This heavenly thing emanated an impression of being older than the actual universe, bringing up a greater number of questions than it answers. How should an arrangement exist that begins before our universe? Or is the speculation of how things came to be false? Join us as we embark on an odyssey coordinated by the discoveries of the James Webb Telescope. The mysteries of a 13.8 billion-year-old cosmos await the journey to unravel these immense secrets, which has scarcely begun. In a far-off corner of the universe, around 200 light-years away, an old star called HD 114283 lives near the Libra constellation. This famous traveler moves energetically through space, offering intriguing brief glimpses into its fierce past. Approximately 12 billion years ago, when our Milky Way was still in its early stages, it ingested a dwarf galaxy that once called it home. However, what truly piques our infinite interest in HD 114283 isn't simply its rapid cycle. It's its astonishing age. Among the heavenly objects we've seen, it remains one of the oldest, earning the charming moniker Methuselah's star, in contrast to the biblical figure Methuselah, who legend has it lived for a considerable length of time. Originally estimated to be a stunning 16 billion years old, the most recent estimates suggest a somewhat younger age of 14.46 billion years, with an edge for error of 0.8 billion years. This revelation about its age has confounded stargazers. After all, the age of the universe, as determined from the cosmic microwave background, hovers around 13.8 billion years. This issue raises colossal questions about the star's age, the universe's age, and even the precision of our dating methods. We should dissect it. Sorting out the age of heavenly objects can be a genuine riddle. Take stars, for example. Like the sun, they're similar to eternal lights, maintaining their brilliance, temperature, and size for billions of years, making them captivating to age. Space experts use changes in brilliance and variety as hints, coordinating these with models to understand how stars develop over time. One age giveaway is the speed at which a star spins like a wheel. Stars slow down over time, and by contrasting the rotational velocities of stars at various ages, cosmologists have worked out a sharp stunt called gyrochronology. Stars also spill their age secrets through magnetic flares and emissions of energy on their surfaces. These lively signs give space specialists, aka the space investigators, a way to listen in on heavenly discussions. With cutting-edge techniques like astroseismology, they tune in for vibrations caused by waves traveling through a star's interior. These vibrations can reveal a star's age. For instance, applying this technique to the sun, space experts have decided its age to be 4.58 billion years. Now, back to Methuselah's star. The old transmission around it isn't simply conflicting. Cosmologists characterized it with an advanced age by analyzing its grandiose beginnings. Stars can be classified into groups based on how much bling or heavy elements like iron they have. Our sun is a metal head, belonging to population 1, while Methuselah's star resembles an old artifact from population 2, with fewer heavy elements. It's the heavenly wink-out that assists cosmologists in playing enormous archaeologists, unwinding the age accounts of these sublime beings. Now, imagine a gathering of stars, hypothetical population 3, which stargazers suspect may be the universe's oldest jewels. However, they're still hiding behind the scenes and haven't yet shown up in our telescope spotlight. Space specialists suspect these stars may be the legends of creation, containing practically no heavy elements. To get a handle on the vast arrangement, we really need to rewind to the universe's initial days, just after the Big Bang. Picture an interminable kitchen filled predominantly with hydrogen and helium, the universe's principal fixings, around 92% hydrogen and 8% helium, or if you average it, around 75% hydrogen and 25% helium. In this huge troupe, the first entertainers on stage were the population 3 stars. They were gigantic and hot, consuming their fuel quickly, changing hydrogen and helium into heavier components. When these early cosmic beasts detonated, they spread these heavy components into the vast range. Next were the population 2 stars, forming a late but still significant chapter in mankind's early days. Their original materials were packed with heavy components, especially iron. Many of them went through their heavenly life cycles, exploding into cosmic events and adding more heavy components to the universal mix. Finally, the population 1 stars, including our Sun, arose as vast amateurs, forming from cutting-edge gas mists mingling with remnants from the earlier population 2 stars. Now, the focal question: does the tremendous story toss an endless bend at the hypothesis of the old Big Bang? It's a head-scratcher. Yet here's the curve. There's a 70% chance that Methuselah's star, the ancient heavenly wanderer, could be around 13.66 billion years old. There's a 13.66% chance that this ancient star's age is playing outside the inestimable rulebook. Moreover, there's a 15% chance it's not as old, simply more youthful. Imagine rolling a standard 6-sided die and expecting a specific outcome. In any case of what these inestimable twists throw at us, one thing is certain: Methuselah's star isn't simply a giant veteran. It's the granddaddy of stars we sorted out how to give it an age, a name that is darn exact. Now, here's where it gets great. Rather than scratching our heads about where Methuselah's star could be 2 or 3 billion years older than its huge neighbors, how about we flip the cosmic content? Consider the possibility that the actual universe isn't as youthful as we once naturally suspected. We've been attempting to make heads or tails of the limitlessness of space. Assuming we turn the whole history of the universe into a vast schedule, with the Big Bang as the most fantastic New Year's firecrackers, Earth wouldn't join the infinite stage as late as possible into December 31st human recorded history. That is only a blip in time covering just the last 10 seconds. Our cosmic analysts decide the universe's age by looking at old starlight 200 or 300 million years after the Big Bang. As the universe extends, it gives this light a huge makeover known as redshift. By figuring it out on both distance and extension, experts have pronounced a general season of 13.8 billion years. Yet hang on. Since the Big Bang, this circumstance is going to get intriguing. A study from the University of Ottawa suggests the universe may be an incredible 26.7 billion years old. Professor Rinder Gupta gets on a charming hypothesis from 1929 made by Swiss space expert Fritz Zwicky, and it's stirring up our grandiose understanding. This hypothesis suggests that as light particles or photons travel through the boundlessness of space over time, they lose a portion of their energy. This thought doesn't perfectly line up with what we've seen through our telescopes. Gupta proposes an infinite compromise. He suggests we can mix this hypothesis with our ongoing comprehension of a developing universe, making a mixture clarification for the redshift phenomenon. Now, locking in, changing the universe's age to an incredible 26.7 billion years is no small feat. Gupta adds one more wind to the cosmic mix by joining the light loss hypothesis with developing coupling constants, a brainchild of hypothetical physicist Paul Dirac. This thought suggests that the way particles interact may have changed over time. And hey, researchers have a past filled with tweaking the cosmic clock. Back in the 1920s, Edwin Hubble thought the universe was just a simple 2 billion years old. We've progressed significantly from that point forward, refining our cosmic math and expanding the universe's age, like bringing a giant leap into our cosmic understanding. However, whether this new perspective turns into the cosmic norm is still up in the stars. Whether human history is a straightforward blip of 10 or 5 seconds in the great plan of the universe, one thing is certain: the universe is a motherlode of old marvels and perpetual motivation. Looking to our vast lawn, the Milky Way, there's a staggering cosmic tango occurring in the universe. Ongoing appraisals hint that stars on the edges of our universe are swaggering their stuff in slow motion compared to their companions in other cosmic systems. What's the galactic scoop? Well, there are a couple of speculations. One hypothesis is that our Milky Way may be running really short on an imperceptible cosmic fixing called dark matter. This subtle substance impacts the gravitational dance of celestial objects. There's a heavenly mystery involving dark matter, the strange substance we can't see, yet it appears to play a gravitational to and fro in the universe. One possibility that is shaking our tremendous comprehension is that maybe we've been assessing dark matter wrong. our general compass may point off-kilter. Here's where the European Space Agency's Gaia satellite steps into the inestimable spotlight. It's like our cosmic inspector, giving complex insights into the dance of almost 2 billion stars in our Milky Way. Consider it an enormous improvement test. The satellite's exact estimations have driven space experts to reconsider their cosmic notes. Stars at the external edges of our Milky Way appear to be moving slower, testing our old suspicions about their paces. How do star speeds spill the grandiose beans about? A cosmic system's mass? It's like really taking a look at the size of a party by how rapidly individuals are moving. Equipped with Gaia's information, space experts assess the absolute mass of our system's gas, dust, stars, and that subtle dark matter to be around 200 times the mass of our Sun. It seems like an inestimable heavyweight, yet here is the twist. It's multiple times less than we previously suspected. One hypothesis to settle this galactic riddle proposes we might have been altogether too cumbersome with our dark matter gauges. Perhaps there's less dark matter out there than we once thought. Anyway, hang on. Estimating a system resembles attempting the unthinkable. The data could have a couple of peculiarities, or our astronomical measuring tape could require some changes. On the other hand, other exploration groups have joined the enormous assessment, and they all seem to be murmuring the same universal tune. If this unprecedented disclosure holds, it's like opening a new chapter in our vast material science course. A turn that could make us reevaluate not just our own Milky Way, but every sparkly corner of the universe. As Stacy McCarr, a space master at Case Western Reserve College, puts it, this could be a huge game-changer. Returning to the 1970s, when stargazer Vera Rubin and her huge group set out on a divine mission, their objective was to concentrate on how stars moved in various galaxies. The inestimable playbook proposed that stars on the edges of a cosmic system ought to be slow movers compared to the zippy stars nearer to the middle, like how Neptune takes its time circling the Sun while Mercury is the timeless speedster. However, what Rubin and her group found was a vast shock. Stars at the far reaches of galaxies were moving at almost the same speed as those nearer to the cosmic dance floor. Imagine a giant disco where everybody, regardless of where they are, is moving to the same beat. This gigantic disclosure suggested the presence of something confusing and imperceptible, dark matter, the inconspicuous heavyweight champion that forms huge halos around galaxies. Contemplate early space specialists like Copernicus and Kepler. We've advanced so much from that point forward, but we're still the newbies wide-eyed at the cosmic wonders, attempting to disentangle the universe's insider secrets. Our Earth is like a minuscule island in the immense expanse of space, twirling around the Sun, encompassed by endless stars. Our mission for significance among the stars is at the core of scientific exploration. In any event, when answers shock us, this interest keeps us voyaging further into the universe. It's a ceaseless venture where every reaction brings new questions, guaranteeing our astonishing assessment never stops. The universe continues to astound us with its immeasurability and intricacy. Every revelation takes us deeper into the complex embroidered artwork of cosmic history, disclosing the basic principles that govern our reality. Continuous exploration has shown that galaxies aren't isolated entities, but are interconnected through a mind-boggling web of dark matter and gravitational forces. This understanding leads us to rethink our models of galaxy arrangement and advancement. Quite possibly the most captivating part of galactic research is the idea of gravitational waves, swells in spacetime brought about by probably the most extreme events known to humankind, like merging black holes or neutron stars. Previously identified in 2015, these waves offer a better approach for noticing the universe, providing bits of knowledge that traditional telescopes could miss. They open a window into phenomena that are imperceptible to electromagnetic radiation, permitting stargazers to concentrate on events from the early universe and improve our understanding of the fundamental forces at play. Moreover, analysts are additionally exploring exoplanets, planets circling stars outside our planetary system. The revelation of potentially habitable worlds raises huge questions about the chance of life beyond Earth. Methods like transit photometry and radial velocity measurements help identify these far-off planets, uncovering other planetary systems that challenge our assumptions of how planetary systems ought to form. A portion of these exoplanets lie in their star's habitable zone, where conditions might be ideal for liquid water, a critical element for life as we know it. As we probe further into the universe, the role of artificial intelligence in analyzing immense sums of data becomes increasingly critical. AI algorithms can identify patterns and anomalies in cosmic light curves, leading to the discovery of new celestial bodies and phenomena at a speed previously unimaginable. This collaboration between human intuition and artificial intelligence propels us into a period of remarkable galactic discovery. The universe continues to astonish with its complexity and diversity. One particularly intriguing phenomenon is the concept of rogue planets, worlds that drift through space, unbound to any star. These solitary wanderers raise compelling questions about planetary formation and evolution. Estimates suggest there may be billions of rogue planets in our galaxy alone, challenging the conventional understanding of planetary systems. In addition to rogue planets, the study of cosmic microwave background radiation, CMB, provides crucial insights into the early universe. This faint glow, a remnant of the Big Bang, allows cosmologists to map the universe's structure and composition, revealing fluctuations that hint at the seeds of galaxies. Gravitational lensing, another captivating aspect of astrophysics, occurs when massive objects like galaxies bend light from distant stars, creating distorted images. This effect not only enhances our ability to observe the far reaches of space, but also helps in understanding dark matter's distribution. Furthermore, as we continue exploring exoplanets, the discovery of biosignatures, chemical indicators of life, fuels our quest for extraterrestrial organisms. Projects like the Transiting Exoplanet Survey Satellite, TESS, and the upcoming James Webb Space Telescope promise to unveil more about the conditions that could support life, potentially transforming our understanding of life in the cosmos.